I think that's very good. I mean, who knows? You might not even need me soon enough, but let's take it step by step. Okay, the 20th term of an arithmetic series is 131, and the sum of the 6th to 10th terms inclusive is 235. Find the sum of the first 20 terms. What I would recommend we do to start with is just try and put the information in the question into some equations. What's the formula for the nth term of an arithmetic series? Excellent. We know T20, we can put 131 here. Good. And let's just do a quick step of simplification. A plus 19 times D is 131. Cool. What's the formula for the sum of the first n terms of an arithmetic sequence? Excellent. How would we represent algebraically the sum of the 6th to 10th terms inclusive? Yeah, I do know what you're saying. I think we can do it a little bit easier. Here's what I think we can do. We could do it the other way, but what we're going to do is we're going to substitute into here. If we did T6 plus T7 plus T8 plus T9 plus T10, we would have to put this so many times. If we take our formula here, we're going to have that minus that. And so what is n here? Excellent. So let's just go through a few steps of simplification. 5 minus 1 is 4. 10 minus 1 is 9. 10 over 2 is 5. And we can even do something a little sneaky here. We can take this factor of 1/2 and just multiply that into the brackets. We're going to go a little bit further. We're going to expand the brackets and collect our like terms, and then we're going to put it into an equation equal to 235. Expanding our brackets here, I should put in equal signs. Excellent, good job getting that. Now we can say 235 is equal to 5a plus 35d. So now we have these two equations, one up here and one down here, and they each have two unknowns. So we should be able to solve these simultaneously to find A and D. And then we can just use our sum formula. I don't know if there's a shortcut we could use, but this is sort of the full solution where we figure out, okay, well, what is the arithmetic series? All right, let me just check some of the values I got. So I got A is -2. Did you get that? And I got D is 7. All right. So that means this is 19 times 7, which I think I already worked out is 133. This is -4. This is 10. -4 plus 133 is 129. So do you get 1,290? All right. 18, I think, was the next one you wanted to look at. It should seem kind of intuitive, particularly what we were just looking at, that the nth term is the difference between the sum of the n minus 1th terms and the sum of the nth terms. So if you took the sum of all the terms up to n minus 1, what do you have to add on to that to get to the sum of all the terms up to n? Yeah, so all this is saying is the nth term is equal to the difference between those two. So what we're going to do is we're going to take the formula for the sum of the first n terms minus the formula for the sum of the first n minus 1 terms. And we're going to do algebra, hopefully, until we're left with the formula for the nth term. Well, let's have a go. This is going to be n over 2 times, and then let's just copy that, paste the whole thing here, except we'll have n minus 1. Now we want to expand our brackets. I'm going to do something a little bit sneaky first, which is I'm going to pull out a factor of a half, and that's basically going to mean that we can ignore that everything's divided by 2. All right, so now I'm going to expand the brackets in the brackets. Oh boy, lots of expanding of brackets to do. It's so nice when you get it going to complete chaos in the middle and it becomes super long and then like everything just cancels out. Nice, neat, satisfying answer.